on tangent. So let's say you have a circle, dots, which is the center, right? Cool. When you have a tangent, let's try and draw your tangent. Yes, your tangent. That's perfect. So the tangent at this point here, let's call it point B. Let's call this point O, right? And then you have different chords, right? Let's say you have a chord from point B to this point. Boom. You have this chord. Let's call it D. If this chord, that's not right. Yeah, it's better. To this point, it's called point E. And you have another chord here in this point, right? Let's call it this angle B1, this angle B2, this angle B3. Okay, and it's have A and C. That's what you have, right? That's what you're seeing. Now, the theorem says that so if you are given AC as tangent, right? Then you have this triangle here that touches the tangent at point B, and if this triangle touches the point B, then angle B1, which is this angle B1 is equal to angle E, which is this angle. This is a theorem, and the reason why is that is because, let me give you a nice reason. The reason why is because they say it's an angle between a tangent. Others, they just write tan, which is okay, and a chord. So it's an angle between a tangent, this is your tangent, and chord, this is your chord. So it's an angle between a tangent and a chord, this angle here. This angle is equal to this opposite interior angle. This angle is equal to the opposite interior angle. I repeat, this angle here, which is an angle between the tangent and the chord, is equal to the opposite interior angle. Right? So that's another theorem. And how will you apply this theorem in real example? Okay, cool. Let me give you an example. Your example will be, you have, let's just say find x. I've been using x a lot to say y. Find y, right? And you're given a circle. The circle has a center O, which is chilled, and you're given this here. And let me write it that way. Let me just first write your tangent, which is gonna make things a little bit better. This is B, this is A, this is C, this is D, this is E. Okay, this is what you're given, right? That's what literally you are given. You know that this is your tangent, right? And then we have this chord, and we have this the triangle that touches the point B, right? So given DE is a tangent, right? And then we have this circle, this triangle touching the edges of the circle, and then one of the edges is the point where it meets with the tangent. Then, so what you have is, we're given this is B1, B2, B3, and you're told that B1 is equal to X, right? And you're told that this here, okay, we said is Y, so let's stick with the notation. Y, so you're told this here is 30 degrees. The question is find Y. You're given D is a tangent and B1, this angle here, is Y. And then find Y. What you gonna say? You're gonna say, oh, cool. Y is equal to angle B1, and we know angle B1 is equal to angle C, this angle here. And this angle here is 30 degrees. And the reason is simple, really. The reason is because it's an angle between a tangent and a chord. It's an angle between a tangent and a chord. And that's your answer. It's awesome, right?